Have you ever accessed any website like google.com, yahoo.com, or any other website? How do you access those sites? You access those sites using their names like www.google.com. But actually, that site has a hidden IP address with it, which in my case, for example, is 142.250.194.196. Similarly, in my network, I access server, which is a database server. That server also has IP address assigned to it within that network. And as a user, I access that server as well by its name. So we are seeing that IP address act behind the scene. Every host running on the internet or in a network has a unique IP address assigned to it within that network. Without that IP address, the host or the system cannot connect or communicate with other system in that network. And we use names to access these systems because names are much easier to remember. We cannot remember all the IP address assigned to a number of hosts. There are millions of hosts or devices connected over the internet, and it is impossible to remember all these IP addresses. Let us see how we can find the IP address assigned to a particular machine. We have different platforms like Windows, Linux, Mac, Android, and there are different ways of getting the IP address from these systems. The operating system like Windows, Linux, Mac also provide UI where you can navigate to different options or menus to find the IP address assigned to that particular system. We can also use a few commands which will help you to find the IP address assigned to that particular system. For example, in Windows system, we use the command ipconfig. When you type this command, you will get an output which specifies the Ethernet or the network card that IP address is assigned to and the IP4 address. In this case, for example, IP4 address assigned to this Ethernet adapter local area connection is 192.168.0.100. It also shows some other informations like subnet mask, which in this case is 255.255.255.0, and the default gateway, which is the router for this particular system. All the requests passing from this host to the internet or other host to the other networks pass through this gateway only. In this case, the default gateway IP address is 192.168.0.1. Similarly, if you are using Linux systems, then you can use the similar command ifconfig. So when you type this command on the terminal, you will get this output. Here it is showing the IP address of a WLAN0 interface, and the IP address assigned to this particular system is 10.0.0.11. It also shows the broadcast IP address 10.0.0.255 and the subnet mask as 255.255.255.0. Similarly, if you are using Mac operating system, you can use the same command ifconfig. You type this command on the terminal. You can specify the network adapter attached to that Mac machine. In this case, we have the interface name as EN0. So we type the command ifconfig space EN0, and when we execute this command, we'll find the IP address, which is 192.168.1.155, and the subnet mask assigned is shown as a hexadecimal number here. The broadcast IP for this particular host is 192.168.1.255. On an Android system, you can navigate to various options. For example, if you have a Samsung phone, you can go to the settings and then connections. You can select the interface that you want to check the IP address, and then in that setting of that particular interface, you will be able to see the IP address assigned to your Android device. You can also find the router or the gateway IP address assigned to a particular host. There is a Windows command root space print that you can use to find the gateway or the router for your system or your network. If you type this command, you will get an output. If you check the output of this command, you will see there is a root defined which starts with network destination 0.0.0.0 and the NAT mask as 0.0.0.0, and the gateway shown as 192.168.3.10. Remember, this network destination and mask 0.0.0.0 is default gateway for your system, which means all the requests passing from this host to the other network will always pass through this gateway. This IP address of 0.0.0.0 is non-routable. This route is also called as default route or default gateway for that particular host. You can open browser or your system, open this website as https://whatismyipaddress.com. You will get the result which will show the IP address assigned to your system. Most of the cases, this IP address is your ISP address or your gateway or router IP address. This is the public IP. This browser does not show your internal IP address assigned to your system. You can also search the Google search engine. When you type this, what is my IP address, in the search box, you will get the result which displays your public IP address. Use the browser and you will find your live IP or public IP address assigned to your system. All the remote host knows your presence on the internet with this public IP address only. Those systems are not aware about your private IP address, and they do not care about what kind of private addressing you are using. What matters for them is the live IP or the public IP. They create the rule to allow or deny the traffic to their network or the system according to the IP address assigned to you. When you're sitting on your system and you want to find the IP address of the remote host and you know the name of that particular host, for example, you know the host name www.google.com, then how you can find what IP address is assigned to the google.com? Simply use the ping command. Type the command ping space www.google.com, and in response it will display the IP address assigned to the www.google.com. In my case, the IP address I get is 142.250.194.196. In your case, this IP address may be different. Why? Because google.com has multiple servers across the globe. So it all depends which server or host where the Google service is running is nearest to you and is available and able to process your request much faster, will reply or will show the IP address of that particular host. There is another command that you can use to find the IP address of a particular host if you know the name of that host. In this case, we should know the DNS name of that particular host. Like here in our case, we are using www.google.com. So simply type the command nslookup space www.google.com, and then it will return the IP address assigned to the google.com. Now, when we are learning about IP addresses, there are very few basic things that you should be aware of. I will try to help you to understand or to remember those few terms in a much better way. First is protocol. You must know what is protocol. Knowing about the protocol is a must for every professional. Without knowing what the protocols are, how they work, or you will not be able to manage, administer, or troubleshoot any specific issues related to that particular protocol. Protocols are nothing but the rules of communications. In real life, the analogy for these rules of communication is traffic lights. See, when you're driving your vehicle on the road, you always come across to the traffic lights. For example, there are three colors being used in the traffic light signaling. The red color specifies that you must stop, while the green says that it's time to drive and go. The yellow means please wait. What happens if you do not follow this protocol? If you do not follow this protocol, means you are not following the traffic rules, and the result will be there will be challan. There may be a case of accident or loss or damage to the property or the people. That's why these rules of communication or traffic rules are created, so as to avoid any kind of damage or loss to the property or the people. The next thing is one of the protocol that we are learning here is internet protocol. So you should know what is internet protocols. Just remember that IP protocol is nothing but a part of TCP/IP protocol suite. Has already told that it works behind the scene, which helps the device or the host connected in a network to communicate with the host or the devices on that network or to the remote network. Real life analogy for the IP address can be your postal address. IP address is also an address, and postal address is also an address, which means that it identifies where you are located. In real life, suppose you want to deliver a parcel to a particular person, then you must know or you must specify the complete postal address of that person on the parcel. Otherwise, that parcel cannot be delivered, or it may be delivered to the wrong person. DNS. DNS stands for Domain Name System. It provides name resolution, which means that it helps to convert the host name to the IP address. In our previous example, we use the host name www.google.com. And how we get the IP address? We get the IP address with the help of DNS system. A host and name resolution query to the DNS server, and the DNS server returns the IP address of that particular host, and then we connect. Similarly, if you know the IP address, you can know the host name assigned to the particular host. So DNS do both things. It converts host name to the IP address and IP address into the host names. With the help of DNS servers, now we no longer need to remember all the IP address assigned to host. We can access the host by their names, like google.com, yahoo.com. We are no longer concerned about what IP address are assigned to those. Real life example of DNS can be a phone book. A phone book or a yellow page is a book of record of people or the organizations and their corresponding contact numbers. So if we know the person name or we know the organization name, we can search which are placed in the sorted order, and when we find the name in the book, then we can find the contact number of that particular organization. Next is format of an IP address. At a higher level, the IP address consists of two parts. The first is the prefix and the second part is suffix. The first part is prefix, which is normally the IP address of the network and called as the network address. The second part of an IP address is suffix, which is shown as the host address. These two parts makes a complete IP address. As in our real life analogy of postal address, we have a society address, and then within that society we have our own house number. That house number specifies our location in that society. Similarly, in an IP address, the host address specifies the location of the host in that network. For example, if you have an IP address assigned to a machine which is 192.168.2.23 and the prefix is 192.168.2.0, means this is the network address for that host, and within that network the location of this host is the host address, which is suffix as 0.0.0.23. So 23 is the location of that host in the network 192.168.2.0. Format of an IP address. Let us see how the IP address is represented. Since computer is a digital electronic device, it needs the data to be in binary format so that it can process. In the binary format, the IP address is a 32-bit IP address. 8-bit makes 1 byte. 1 byte is equal to 8 bit. So if we divide 32 by 8, we get 4 byte. We can say that IP address is a 4 byte long number. For example, say this. This is an IP address of 32-bit length. So it consists of the combination of binary digits 0 and 1. This 32-bit number is denoted as 4 byte or octet separated by dots. We take 8 bits at a time and then we represent them as 1 byte or 1 octet. So first 8 bits makes byte 1, the second 8 bit makes byte 2, the third 8 bits make byte 3, and fourth 8 bit makes byte 4. Again, the example for this binary notation for the IP address will be shown as here. You see these 8 bits are separated dots. If you want to know the maximum number of IP address which can be created, you can get that number by 2 raised to the power 32, which makes the total number of IP address 4294967.296. With the increase of number of devices connected over the internet, this number may fall short. To take care of this, the IP version 6 is introduced. We will learn about IP version 6 sometime later. Remembering the 32-bit binary number is not easy for us. That's why we represent the IP address in decimal format. And to represent the IP address into the decimal notation, there are rules that we need to follow. As we already said that 8 bits represent 1 octet. So we convert those 8 bits into the decimal number, and then we represent the IP address using those decimal numbers. For example, this IP address in the binary, we usually convert the 8 bits into the decimal, and then we denote this IP address as 251.96.126.121. Remember, each number in this set or the octet can range from 0 to 255. The decimal number 0 means that all 8 bits are set to 0, while the decimal 255 means all the 8 bits are set to 1. So the full IP address range in the decimal number system can goes from 0.0.0.0 to 255.255.255.255. Please also make note that the first IP address and the last IP address are not used in the IP addressing. The first IP address, which is 0.0.0.0, is known as the default net, and it is a non-routable IP address, which is designated as invalid and non-applicable. And the IP address 255.255.255.255, which is the last number in the IP address range, is used to broadcast the message. Now we learn about that IP address has two parts: network address and host address. Now the question is that if we have an IP address, how can we know which part of that address is the network address and which part is the host address? Answer to this question is using the subnet mask. Using the subnet mask, we can find out which part of the IP address is the network address and which part is the host address. As an IP address, subnet mask is also a 32-bit long address. If we write both IP address and the subnet mask in the binary format and then we ended these two numbers, we will get the network address. For example, let us say we have a host with the IP address 192.168.1.152 and the subnet mask is 255.255.255.0. Then We convert this IP address written in the decimal notation into the binary notation, and then we enter these two values. We'll get the result which will provide us the network address of this host, which in this case is 192.168.1.0. So we can say that subnet mask help us to extract the network ID and the host ID from an IP address. So 192.168.1.0 is the network address, while 192.168.1.152 is the host on that network. There are types of IP addresses that we use in the network. There are basically four types of IP addresses that we have. The IP address that we have can be a public IP or it can be a private IP. Public IP address is also known as the live IP. We also have the IP address which can be static, means fixed, or which can be changing, or we can say that they are dynamic. The dynamic IP address is normally provided by a server known as the DHCP server. A website running on a host in the network or the internet also have the IP address assigned to its host. A website can have multiple IP address or it can have a dedicated. A website can have public IP, it can also have private IP. Access a website over the internet, it must have a public IP. In case of website hosting, we also have two other type of IP addresses. One is the shared IP address, other is the dedicated IP address. The shared IP address means the IP address assigned to a particular website can be shared or assigned to other websites. So one IP address can represent multiple websites at the same time. The advantage of using shared IP address is lower cost. We can host multiple websites using one single IP address. A dedicated IP means that a website has a unique IP address assigned to it. That IP is reserved for that particular website. The advantage of having a dedicated IP address is that your website looks more authentic. There are less chances that your website will be blocked or blacklisted. While in case of website having the shared IP address assigned to them, if there is any problem with any of the website or host which are using this shared IP address, that shared IP can be blacklisted, which means all the website or the host will be affected because of that blacklisted. If your website has a dedicated IP address, it can also be accessed by the IP address instead of names, provided that there are wherever rules configured or permissions provided to access the website using the IP address. You see, the most of the websites are secure by using SSL certificate. If you have a static or dedicated IP address assigned to your website, it is much easier to install SSL certificate and to run service like file transfer in more authentic way. There are 5 types of IP addresses classes. The class starts from class A, class B, class C, class D, class E. The IP addresses are allocated by the internet, which is an organization which administers the IP addressing. The IP addresses are divided into classes. All these 5 classes can be identified by the first octet of the IP address. We have class A, B, class A, class B, class C, class D, class E. As per the rule, we need to look at the first octet of the IP address to find the class of the IP address. We can find the class of the IP address by looking at the first octet, by looking at the number written in the first octet of the IP address. If the number is from 1 to 127, it will be class A IP. The last number 127 in the first octet is reserved for a specific purpose, so we do not use that. So the range that we can use in for class A IP addressing is from 1 to 126. The class B IP address range from 128 to 191 in the first octet. Similarly for the class C, we have the number 192 to 223, the first octet. In case of class D, we have the number from 224 to 239 in the first octet. And in case of class E, we have the number from 240 to 254 in the class E addressing. In case of class A IP address, if you write the IP address in the binary format, the first bit, the first octet is always set to 0. Thus, the first octet will range from 1 to 127. In case of class A IP address, the IP range 127 is reserved for loopback IP addressing. This series of IP address we cannot use to assign to the network interface because these are reserved for diagnostic. The default subnet mask for the class A IP address is 255.0.0.0. If we return the class A IP address in binary format, it will look like this. The first bit in the first octet is always 0, so other bits in the first octet will represent the network address, while the other bits in the other 3 octets represent the host address. If you are using class B IP address, in case of class B IP addresses, the first 2 bits are set to 1, 0. For example, you will see the binary notation of class B IP address in the first octet as 10. The class B IP address will range from 128.0.x.x to 191.255.x.x. We can have total number of 2 raised to the power 14, and the maximum number of hosts in one class B IP address can be derived as 2 raised to the power 16 minus. In the binary format, the class B IP address will look like this. In case of class C IP address, the first 3 bits are always set to as 110, and in the binary format, the first octet of the class C IP address will look like this. The IP address from 192 to 223 range will belong to the class C IP address. Thus, the class C IP address will range from 192.0.0.x to 223.255.255.x, and the default subnet mask for the class C IP address is 255.255.255.x. Thus, the class C gives the maximum number of possible network, which is 2 raised to the power 21, and the minimum number of hosts in one class C network, which is 2 raised to the power 8 minus 2. The class C IP address in its binary format will look like this. In case of class D IP addresses, the first 4 bit in the first octet are always set to as 1110. In binary format, the first octet will look like this. The IP range for the class D network will start from 224 to 239 in the first octet. Thus, the class D IP address will look from range 224.0.0.0 to 239.255.255. The IP range, the class D IP address is used for multicast. In multicast, data is not destined for a particular host, but it is sent to multiple hosts in the network. The class D IP address does not have any subnet mask. The last class, the class E IP address, are reserved for experimental purpose, research and development and study. IP address in the class E will range from 240.0.0.0 255.255.255.250. Like class D IP addresses, this class is also not used. This class is also not assigned with subnet mask.